Welcome to The Explainer. Today, we're using a concept I like to call the fashion designer strategy to tailor your Cambridge database answers perfectly to the question, leaving absolutely no loose threads. Think about a high-end bespoke fashion designer for a second. They don't just grab a massive, heavy piece of fabric, throw it at their client, and hope it fits. That would be ridiculous, right? They measure, they cut, they tailor, and they ensure every single stitch serves a highly specific purpose for that exact individual. Yet, when students sit down to take their Cambridge computer science exams, specifically looking at past papers like the Legacy 9713 or the current advanced ones, they completely abandon this logic. They get nervous, they grab every single fact they've ever memorized about databases, and they just throw it onto the exam paper, desperately hoping the examiner will dig through that mess and find something that fits the mark scheme. Well, today, we put a complete end to that. We are going to transform you from someone who just dumps raw data on a page into a strategic designer of top-tier, precision-engineered exam answers. Here is our quick roadmap for today's masterclass. We'll outline the challenge, lock down the core database terminology, dive into the methodology, test your skills in an interactive exam workshop, and then wrap up with the final system. Let's get right into it.
Okay, let's start by addressing the massive elephant in the room. Why do otherwise incredibly well-prepared students consistently bleed easy marks when asked about basic database terminology? Whether you're studying the foundation syllabus codes like 0417, 0478, 0983, 0984, 2210, or our main focus for today, the advanced 9618 AS and A-level, the principal examiner reports highlight the exact same tragedy year after year. It's actually kind of mind-blowing. You have students who can sit down and code incredibly complex, multi-layered algorithms flawlessly, but they somehow stumble and lose points when asked to simply explain the theoretical architecture of a relational database. It is not a lack of knowledge, guys. It is a lack of exam technique and precision. They completely fail to tailor their deep knowledge to the specific, rigid constraints of the question being asked.
We see this exact scenario play out constantly with two very specific types of students. Let's call them Alex and Sam. First, we have Alex. Alex suffers from major knowledge overload. When the exam question asks for a brief description of an entity, Alex panics and writes an entire novel containing every single raw computer science fact they can possibly remember from the textbook. They talk about primary keys, foreign keys, normalization, everything. But here's the problem. There is zero analysis. It's just a massive brain dump. They aren't answering this specific question. On the other side, we have Sam. Sam rushes. Sam thinks they know it all. Sam sees the word database in the prompt and immediately starts writing a generic, pre-memorized answer, completely ignoring the absolutely crucial command words like evaluate or analyze. Sam misses the requirements entirely because they're already thinking about the next question. Both of these students intimately know the material, but both are actively losing vital, easy marks because they simply aren't tailoring their answers to the exact shape of the prompt. And this brings us to a direct quote from a Cambridge senior examiner that I want you to internalize. They stated, "Most students lose easy marks on database terminology, but after this, you won't be one of them." Think about what that actually means. The examiners genuinely want to give you these marks. They set up these terminology questions as foundational building blocks. They are intended to be easy, confidence-boosting wins before you have to move on to the really brutal, complex SQL queries or the deep normalization steps later in the paper. When you master the precise definitions, the causal relationships, and the integration with other syllabus areas, you unlock these easy marks and build an impenetrable safety net for your overall grade.
Moving on to Section 1, Database Terminology, Mastering the Core 6.
Now, we need to get serious about vocabulary because there is a massive, fundamental difference between theoretical architecture and practical programming, and the examiners will absolutely punish you if you mix them up. Let's break down this mapping. First, an entity. An entity is a theoretical, abstract, real-world object or concept that we want to store data about. Think of the concept of a student or a car. But when we step out of theory and practically implement that entity into a working database, it becomes a physical table. Next, an attribute. This is a theoretical characteristic of that entity. So if the entity is a student, the attribute is their hair color or their date of birth. When we actually sit down and build the database software, that attribute becomes a field, which is represented as a column in your software. Finally, a tuple. This is the one everyone gets wrong. In mathematical set theory, a tuple is an ordered list of elements. In our theoretical database schema, it represents one complete, single instance of an entity. But practically, when you type that specific user's data into your database row by row, it is called a record. Examiners absolutely love to test if you know the difference between the theoretical blueprint on the left and the practical software system on the right. Mixing these up is a guaranteed way to lose those easy marks, so you need to have this mapped perfectly in your head.
Before we get into the exact methodology of how to apply these terms, I want to make sure you have the ultimate advantage. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Seriously, don't miss out on these weekly strategies.
All right, Section 2, the methodology, moving from concept to application.
So how do we actually apply this in the exam room? Systematic processing within computer science follows this highly specific, standardized sequence to ensure you algorithmically decompose every complex exam question. It's a 5-step mental algorithm. Step 1. Identify key elements. What is the actual scenario? Are we dealing with a hospital database tracking patients or a school system tracking grades? Context is everything. Step 2. Apply relevant principles. Which of our core 6 terms that we just learned actually apply here? Step 3. Execute analysis with clear working. This is the heavy lifting where you connect the dry theory to the specific scenario. Step 4. Verify results. Take a breath and ask yourself, did you actually answer the question asked, or did you do a SAM and rush it? Step 5. Present in the appropriate format. Are you using the correct technical notation for a relational schema? This step-by-step decomposition is the exact algorithmic thinking required to structure a flawless, highly tailored answer.
Now let's talk about execution. We can completely transform Alex's flawed, messy data dump into a perfectly tailored response using the Peel framework. This is how you link everything back to the question. The Peel framework stands for point, evidence, explanation, link. Think of it as your structural blueprint. First, you make your technical point. For example, explicitly identifying a primary key in the schema. Next, you provide evidence directly from the provided exam scenario. You quote the specific data, like student ID 405. Then you provide your explanation. You detail exactly why this specific attribute uniquely identifies the tuple within this relational structure. Finally, and this is the most important part that students always forget, you link it back to the question-specific context. Does this primary key solve the specific data redundancy issue the examiner asked about? This strict framework forces you to be the fashion designer. It guarantees you're tailoring every single sentence so there are absolutely no loose threads for the examiner to dock marks on. If you want the absolute highest marks, you need to understand that computer science doesn't exist in a vacuum. Principal examiner reports explicitly state that candidates who demonstrate specific evaluative traits, especially making cross-topic connections, achieve significantly higher marks. But what does a cross-topic connection actually look like in a database terminology question? It means linking the concept of a primary key attribute to the efficiency of search algorithms that you learned about in a totally different module. It means understanding how your choice of data types for your database fields directly impacts the overall space complexity and memory allocation of your system. It means taking a step back and analyzing the trade-offs between creating a perfectly normalized relational structure versus the processing time complexity required to execute complex, multi-table join queries. When you justify these architectural database decisions with hard, measurable evidence, you immediately elevate your answer from a standard B grade to a definitive, undeniable A star. Hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back to it.
Welcome to Section 3, the interactive exam workshop. Get ready to think fast.
Before you attempt the challenge I'm about to give you, I need you to carefully review these top 3 mistakes. These are pulled straight from examiner reports, and they consistently ruin otherwise perfect database answers. Mistake number 1, forgetting to check overflow or edge cases when defining field data types. For instance, if a field is meant to store a telephone number, did you consider the edge case of an international dialing code that requires a plus symbol? If you set it to an integer, it crashes. Mistake number 2, missing boundary conditions. If an attribute has a strict validation rule, say values between 1 and 10, did you test the exact boundaries? What happens if the value inputted is precisely 0 or precisely 11? And mistake number 3, which is the absolute most common, providing generic, textbook answers lacking specific context. If the exam question is about a library database, your answer must actively mention books, borrower IDs, and due dates, not just generic tuples and entities. You must wrap the theory in their context. All right, it's challenge time. I want you to imagine you are sitting in the exam hall. You have exactly 60 seconds. Scan the complex database scenario we are presenting and pinpoint exactly which boundary condition or edge case has been completely ignored in the schema. Imagine this is a high-stakes past paper question for syllabus 9618. Look closely at the database tables provided. Look at how the attributes are defined. Now really look at the sample records they've given you. Where is the fatal flaw? Is there a tuple that violates entity integrity? Is there a field that hasn't accounted for a specific data format, like an exceptionally long name or a negative currency value? This is exactly the kind of forensic analysis you must perform under pressure. Take a mental snapshot, find the error, and formulate your appeal response.
Okay, time's up. Now, to ensure you never blank on these crucial terms when that exam anxiety hits, you need a memory hack. Create a simple mnemonic using the first letters of our 6 core terms, ETRFTA. That's entity, table, record, field, tuple, attribute. When you are under extreme stress, your working memory literally shrinks. Having a bizarre, funny, or highly memorable phrase to unlock these 6 terms can be an absolute lifesaver. For example, you could use every table requires fields, tuples, attributes. Or honestly, make it totally weird so it sticks in your brain. Elephants think, radishes feel truly awful. It really doesn't matter what the phrase is, as long as it immediately triggers the rapid recall of both the theoretical and practical terminology we mapped out earlier. Build your safety net.
Let's bring it all together in Section 4, the final system.
I want you to look closely at this comparison, because the method mark strategy proves that even if your final output is completely wrong, showing your step-by-step algorithmic thinking creates a safety net that literally saves your grade. This is a critical examiner alert. Imagine 2 students get the exact same incorrect final answer when calculating an estimated database file size based on the number of tuples and the byte size of the attributes. The first student just writes down the wrong final number. They get 0 marks, period. But the second student, they write out the calculation formula, they correctly identify the attribute sizes, they multiply by the number of tuples, but they make a tiny, silly arithmetic error at the very last second. The examiner awards that second student multiple method marks because they clearly demonstrated an understanding of the theoretical architecture. Never, ever hide your working. In computer science, your systematic process is just as valuable as your final product.
If you want to guarantee top marks across the entire paper, you must rigorously apply these 3 specific rules to tailor your response perfectly to the examiner's rubric. Rule 1. Command word decoding. Stop being like Sam. Highlight the command word the second you read the prompt. Is it describe, explain, analyze, or evaluate? Let that specific word dictate the depth and angle of your answer. Rule 2. Peel framework application. Never dump raw facts like Alex. Structure every single long-form paragraph with point, evidence, explanation, and link directly to the scenario context. And Rule 3, the time management matrix. Allocate your time strictly based on the mark value of the question. Do not spend 10 minutes writing a beautiful essay-linked explanation for a basic 2-mark definition of a tuple. It's bad strategy.
And the true value of this entire system is in the undeniable results. Students who consistently implement this exact standardized sequence, students who act like fashion designers, tailoring their specific knowledge to the exact shape of the prompt, see an incredible average improvement of 2 full grade boundaries. Moving from a C to an A or a B to an A star is entirely possible when you stop fighting the exam paper and start systematically giving the examiners exactly what their mark schemes demand. It is just an algorithm, and now you know how to run it.
But you have to practice it. Consistency is the only way to secure that strategic advantage. So here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by without having these strategies in your back pocket.
I want to hear from you. Drop a comment below with your target grade for computer science and the absolute biggest challenge you are facing right now. Our team responds to every single comment. Like this masterclass and share it with a study partner who needs a wake-up call on their database theory. Ace the Exams. Your Cambridge success starts here.
As you head back to your revision, I want to leave you with one final provocative thought. Next time you sit down to solve a database problem, I want you to stare at those entities, those attributes, and those tuples, and honestly ask yourself, do I truly have every possible boundary condition and edge case covered? Because I promise you, the examiner will be looking for the exact thread you left loose. Keep tailoring your answers, keep analyzing the data, and we will see you in the next masterclass.